Hi, everybody. So we spent the last lesson looking at sequences, and today we're going to spend looking at a special type of sequence called an arithmetic sequence. And again, sequences are just the list of terms. So they're going to be numbers that are separated by a comma. And then we're also going to look at arithmetic series. And a series is just taking the terms of a sequence and adding those together. Okay, so we're going to talk about how we can find specific terms in an arithmetic sequence. We're going to talk about like identifying what the common difference is in an arithmetic sequence. And then we'll also look at adding terms of an arithmetic sequence together to figure out the sum of an arithmetic series. Okay, so let's start with the definition. An arithmetic sequence is defined as a sequence where the difference between each pair of consecutive terms is the same number. We call that number the common difference D. Okay, so to go from one term to the next, we're going to be adding or subtracting the same number. Okay, so an arithmetic sequence may be defined recursively as a sub 1 is equal to a. So again, for a recursively defined sequence, we usually define the first term or first few terms. So we define the first term, a sub 1 is a, and then every term after that is going to be defined by some formula. Okay, so all of the terms that come after a sub 1, which are going to be a sub n, is going to be equal to a sub n minus 1. So that is the term that precedes a sub n. And then to that, we're going to add the common difference D. Okay, so let's get into some examples then involving arithmetic sequences. So directions here say that an arithmetic sequence is given, and then we're asked to find the common difference D and write out the first four terms. Okay, so for this arithmetic sequence is defined by the formula 4 minus 2n. So if we want to figure out the first term in the sequence, a sub 1, we're going to plug 1 in the place of n in that formula. So that's going to be 4 minus 2 times 1, which is 4 minus 2. So that first term is going to be 2. The second term, a sub 2, will be 4 minus 2 times 2, which is going to be 4 minus 4. So the second term is 0. The third term, a sub 3, will be 4 minus 2 times 3, which is 4 minus 6, which is negative 2. And then the fourth term, a sub 4, is 4 minus 2 times 4, which is 4 minus 8, which is negative 4. So the first four terms of this are 2, 0, negative 2, and negative 4. And then that sequence is going to continue. And then the common difference, to go from one term to the next, what do we add? We add negative 2. So our common difference there, D, is negative 2. Okay, so this next formula is going to be really important for us in this lesson. So this is going to calculate the nth term of an arithmetic sequence. So it says for an arithmetic sequence, a sub n, whose first term is a and whose common difference is d, the nth term is defined by the formula a sub n is equal to a plus n minus 1 times d. Okay, so the nth term a sub n is equal to the first term a plus n minus 1 times the common difference D. Okay, so with that formula in place, we're going to do a couple of examples utilizing the formula. So the directions here ask us to find the nth term of the arithmetic sequence given the following information, and then what is the 12th term. Okay, so for number 1, we are given that the first term a is 6, and then that the common difference d is negative 2. Okay, so if we want to calculate what the nth term is, a sub n is equal to a plus n minus 1 times the common difference d. So we're just going to plug what we know into this formula. So a sub n will be equal to a, which is 6, plus n minus 1 times the common difference d, which is negative 2. And then what we're going to do here is we're going to simplify the right-hand side where we can get this nth term written in terms of the variable n. So if I distribute negative 2 across both of these terms here, then that's going to make a sub n equal to 6. When I distribute negative 2 across both of those terms, we're going to get minus 2n, and then negative 2 times negative 1 is going to be positive 2, which is going to make a sub n be equal to, whenever I combine like terms, we get 8 minus 2n. So that formula there is going to calculate the nth term for any number n. Now, the second part of this question asks us to find the 12th term. So really, that's asking us to find a sub n when n is equal to 12. So a sub 12, when I plug 12 into that formula, we get 8 minus 2 times 12, which is 8 minus 24. So that 12th term is negative 16 in this particular case. Okay, you guys give the next example a try. So pause the video really quick. And I want you guys to find the nth term and the 12th term when a is negative 1 and d is 2. All right, so when we do the same thing for this example, again, a sub n is going to be equal to a plus n minus 1 times the common difference d. And again, we're going to plug the values of a and d in for that formula. So a sub n is equal to a, which is negative 1, plus n minus 1 times the common difference d, which is 2. So I'm going to distribute 2 across both of these terms here. So we get a sub n equal to negative 1 plus, when I distribute 2, I get 2n minus 2, which makes a sub n equal 2n minus 3. Okay, so that formula is going to generate every single term in the sequence. Then if we want to calculate the 12th term, a sub 12, we're just going to plug 12 in the place of n. So that's going to be 2 times 12 minus 3, which is 24 minus 3, which is equal to 21. Okay, so the next example I actually took from one of your homework problems because it asks us for a lot of things. In this question, I want to make sure that you guys are clear in computing all of these things. So directions here say to determine if the sequence is arithmetic. If it is, find the common difference, the 52nd term, the term named in the problem, the explicit formula, the recursive formula, and the 3 terms in the sequence after the last one is given. Okay, and the sequence that we are given here is the sequence containing the numbers negative 13, negative 3, 7, and 17. And then the problem asks us to find a of 23, which is the 23rd term in the sequence. So let's attack this problem going in order. So first off, we want to determine if the sequence is arithmetic. So what we want to do is we want to go from one term to the next and figure out if the common difference is uniform throughout. Okay, so when I go from the first term 13 to negative 3, I do that by adding 10. To go from negative 3 to 7, I do that by adding 10. To go from 7 to 17, I do that by adding 10. So that means that this sequence here is arithmetic. And we can also determine that the common difference d is equal to 10. Okay, so the next thing the problem asks us to determine is the 52nd term. Okay, so we're going to use the formula that we just got introduced to before the last set of examples. So a sub n is equal to a plus n minus 1 times the common difference d. And we want to use that to calculate a of 52. So a of 52 will be a, so the first term is negative 13, plus 52 minus 1 times the common difference, which is 10. So that makes a of 52 equal to negative 13 plus 52 minus 1 is 51 times 10. That's 510. And negative 13 plus 510 is 497. So the 52nd term, a sub 52, is equal to 497. Okay, so again, we've determined its arithmetic. We found the common difference. We found the 52nd term. Next thing we were asked to find is the term named in the problem. So a of 23, so we're going to calculate that next. So if I want to calculate a of 23, I'm going to use the same formula. A plus n minus 1 times d, so our a value is negative 13, plus n, in this case n is 23, minus 1 times the common difference d, which is 10. And then to simplify this here, we get negative 13 plus 23 minus 1 is 22 times 10 is 220. And negative 13 plus 220 is 207. So a of 23 is 207. Okay, so that's the term named in the problem. We want to do the explicit formula next. Okay, so for the explicit formula, we're going to take this same formula and we're going to write that formula in terms of the variable n. So we just want to calculate that formula in terms of n. So a sub n is equal to a, which is negative 13, plus n minus 1, and then our common difference d is 10. So I'm just going to distribute 10 across both of those terms. So we get a sub n equal to negative 13 plus 10n minus 10. And then when I combine like terms, we get 10n minus 23. Okay, so a sub n is 10n minus 23. Okay, so that is the explicit formula. Okay, the next thing we want to find is the recursive formula. So if you remember the recursive formula back at the start of this lesson, the recursive formula is going to look like this. So we need to specify what the first term is, and then we need to write the nth term in terms of the n minus 1 term and the common difference. Okay, so that first term, I'll go ahead and do this up here. The first term, a sub 1, is equal to negative 13 in this case. And then every term after that, a sub n, is equal to a sub n minus 1 plus the common difference, which the common difference is 10. So that right there is the recursive formula for that sequence. And then the last thing the problem asks for is the 3 terms in the sequence after the last one given. Okay, so the last term that's given is 17. If I want to get the 3 terms that come after, I'm just going to keep adding 10 to the preceding term to get the next term. So if I add 10 to 17, the next term is 27. If I add 10 to that, the next term is 37. If I add 10 to that, the next term is 47. So these are all of the things that the problem asks for. And it's a really good example because it's kind of asked us to do everything that we've learned so far in this lesson in particular. Okay, so let's move on to the next one. This next one's a really good problem because it takes what we're learning in regards to arithmetic sequences and it ties it in with another like mathematical concept. Okay, so directions here say, given the following information, find a recursive formula for the sequence. And we are given that the 8th term is 4, and the 18th term is negative 96. So we know based on the last example that we did, if we want to find a recursive formula, there are two things that we have to calculate. We have to figure out what the first term A is, and then we also have to figure out what the common difference D is. And what we can do is we can take our formula here where A sub n is equal to A plus n minus 1 times the common difference D. And we can take these two pieces of information here and plug them into that formula. Now, given what we know in math, if we are solving for two variables, so we're solving for A and we are solving for D, we have to be able to solve a system of equations with at least two equations to solve for two variables. Okay, so if we take the information in that first highlighted statement where the 8th term is 4, then what I can do is I don't know what A is. I know what n is because it's the 8th term. 8 minus 1 is going to be 7. So we know that A plus 7D is going to be equal to what the 8th term is, which in this case is 4. And that right there gives me the first equation in my system of equations. Okay, so that's equation number 1. If we take the second highlighted statement in yellow, the 18th term is negative 96. I can plug that information into that equation as well. Okay, so we don't know what A is, so we have A plus, when I plug 18 in the place of n, 18 minus 1 is 17, D, and that's going to be equal to negative 96. And that right there is the second equation in the system of equations. Okay, so when we're solving a system of equations, we have two techniques that we can use. We can use the process of substitution or the process of elimination, and either one of them would work fine in this particular instance. I'm actually going to use elimination because I can subtract the bottom equation and eliminate the variable A. So if I subtract those two equations, we get A minus A, which is 0. We get 7D minus 17D, which is negative 10D. And then 4 minus a negative 96 is the same thing as 4 plus 96, which is 100. And then when we isolate D, we get D equal to negative 10, which we said that that was one of the things that we needed to determine. We needed to figure out what D was equal to. Okay, once we know the value of D, we can plug into either equation 1 or equation 2 and solve that equation for the variable A, which I'm going to plug into the top equation. So we get A plus 7 times D, which is negative 10, is equal to 4, which makes A minus 70 equal to 4, which makes A equal to 74. And then once we have the values for A and D, we have everything that we need for our recursive formula. Okay, so for our recursive formula, we have to specify what the first term is. So A sub 1 is 74. And then every term after that, A sub n, is equal to the term that precedes it, A sub n minus 1, plus the common difference, which is negative 10. So instead of adding negative 10, I'm just going to subtract 10. Okay. And that right there gives me the recursive formula for that arithmetic sequence. Okay, so that right there, really good problem. It takes what we've learned in regards to arithmetic sequences and ties it in with solving a system of equations. Okay, so really good example in that particular case. Okay, so let's move on to our next topic. And our next topic is to find the sum of n terms of an arithmetic sequence. Now, before I even get into that, I want to pose a question. So I think this question was posed like in Europe several hundred years ago in like an elementary school class. And the teacher asked the students to take the sum of the first 100 positive integers. So you're taking 1 plus 2 plus 3 plus all the way out to 100. And expecting this to take the students a long time, just a couple of moments later, one of the students came up with a solution to the problem, and I want to show you what the 8 or 9-year-old student came up with. So what the student did was he took the first half of those numbers between 1 and 100. So he took the first 50 numbers and rearranged them like this: 1 plus 2 plus 3 plus 4 plus all the way out to 50. And then he took the second 50 numbers, listed them from largest to smallest. So he took 100 plus 99 plus 98 plus 97 plus all the way down to 51. And added those numbers together and saw that when you add those two terms together, 100 plus 1 is 101, 99 plus 2 is 101, 98 plus 3 is 101, 97 plus 4 is 101, all the way down to 51 plus 50 is also 101. So how many terms of 101 do we have? We have 50 terms of 101. So we took 50, multiplied it by 101, and got 5,050 for that sum. Okay, really creative, really interesting approach. That student wound up being like a really famous mathematician, Gauss, and leads us into what we're going to talk about next, which deals with finding the sum of n terms of an arithmetic sequence. Okay, so if we let a sub n be an arithmetic sequence with first term a and common difference d, the sum s sub n of the first n terms of the sequence a sub n is given by this formula, where s sub n is going to be equal to n over 2 times a plus a sub n. Okay, so we're taking the number of terms in the sequence and dividing it by 2. And then we're multiplying that by the first term plus the last term, which is exactly what we did up above here. Okay, so this calculation that we performed, we took the number of terms, which is 100, we divided that by 2 to give us 50. And then we multiplied that by the first term plus the last term. So 100 plus 1 gives us 101. And then we multiplied those two things together to give us our sum. Okay, so let's do some examples illustrating this. So the directions here ask us to find the sum. We are given 1 plus 3 plus 5 plus all the way out to 59. Okay, so when we look at this here, we know that if I want to calculate the sum, I need to know the value of n, I need to know the value of a, and I need to know the value of a sub n. Okay, and I can look at the information given in this problem and figure out that a is equal to 1, so that's the first term. A sub n, which is the last term, is equal to 59. And then what we have to do in order to calculate the sum is we need to figure out the number of terms in that sum. Well, to figure out the number of terms in the sum, we're going to use this formula here, a sub n, which is equal to a plus the quantity n minus 1 times the common difference d. Okay, and I want to solve that equation there for n. Well, I know a sub n, the last term is 59. I know the first term a is 1 plus n minus 1, and then we can look at that sum. Because this is an arithmetic series, we can determine what the common difference d is. So to go from one term to the next in the sum, we are going to add 2. So that's going to make 59 equal 1 plus, when I distribute 2, we get 2n minus 2. And then if I want to solve this equation for n, like when I take 1 minus 2, that's negative 1. So I'm going to add 1 to both sides. So that's going to make 60 equal to n, which makes n equal to 30. And once we know n is 30, then we have everything that we need in order to figure out that sum. Okay, so s sub 30 is going to be n, which is 30, over 2, times the first term a, which is 1, plus the next term, or plus the last term, a sub n, which is 59, and 1 plus 59 is 60. 30 divided by 2 is 15, and 15 times 60 makes that sum equal to 900. Okay, so that's going to allow us to figure out the sum of the terms in that sequence. Okay, last two examples I am pulling from your guys' homework assignment. These are challenging questions here. So these are about as difficult as we can make these arithmetic sequence and series problems. So directions say to determine the number of terms in each arithmetic series. Okay, so we are given the sum 4 plus 13 plus 22 plus 31 plus, and that sum is going to continue. And then we are told that s sub n, so the value of that sum is 1,790. Okay, now what we need to do here is we need to figure out the number of terms in that sum. Well, there's some stuff that we are missing here. Okay, so we know, let's write this down over on the side here. Okay, so we know s sub n is going to be n over 2 times a plus a sub n. Okay, so if we think about like what we are directly told in this problem, we know the sum s sub n is 1,790. We don't know what n is, so we're solving for n in this problem. We know the first term a is going to be 4. So if we're going to solve for n, the piece of information that we are missing in order to solve for n is the value of a sub n. Okay, so that's the missing piece of information that we need to determine in order to solve this equation here for n. Okay, so we want to figure out what the last term in this sum here is going to be. Okay, well, if we take the formula that we were introduced to at the start of this lesson, where a sub n is equal to a plus n minus 1 times the common difference d, what we can do is we can figure out what a sub n is equal to in terms of the variable n. Okay, so like In an earlier example, we looked at finding like the explicit formula for a sub n. We need to figure out what the explicit formula for a sub n is. Okay, so a sub n, we have enough information to figure that out. So a sub n is going to be equal to a. So the first term in this sum is 4 plus n minus 1 times the common difference. So this sum, or this series, is arithmetic. To go from one term to the next, the common difference here is going to be 9. Because 4 plus 9 is 13, 13 plus 9 is 22, 22 plus 9 is 31. Okay, which makes a sub n equal to 4 plus, when I distribute 9, we get 9n minus 9, which makes a sub n equal to 9n minus 5. Okay, and then once we know that is a sub n, we can plug that in the place of a sub n in that sum formula. Okay, so we're going to plug in 9n minus 5. So what that gives us is 1790 is equal to n over 2 times, whenever I simplify what's inside the parentheses, we get 9n minus 1. And then to get rid of the fraction here, I'm just going to multiply both sides by 2. So on the left-hand side, 1790 times 2 is 3580, is equal to, when I multiply the right-hand side by 2 and then distribute, we're going to get 9n squared minus n. Okay, and this winds up being, whenever I subtract 3580 on the right-hand side, that winds up being a quadratic equation. Now, this is a pretty horrendous quadratic equation. The numbers are humongous. I don't think factoring is a legit option, even though you can factor this. So if we use the quadratic formula here, we get n equal to 1 plus or minus b squared, so that's 1 minus 4 times 9 times negative 3580 all over 2 times 9. So that makes n equal to negative 1 plus or minus. That radical winds up becoming 128,881 all over 18. And that radical winds up becoming, whoops, sorry, that shouldn't be negative 1, that should be positive 1. That radical winds up simplifying to 359, so you get 1 plus or minus 359 over 18. And then if you do 1 plus 359, that's 360 over 18. So 360 divided by 18 is 20. And then when you do 1 minus 359, you get negative 358 over 18. And negative 358 over 18 winds up simplifying to negative 179 over 9. Now, in the context of this problem, like, it doesn't make sense for the number of terms to be negative. It also doesn't make sense for the number of terms to be a fraction. So we wind up throwing that solution out. And our only solution to this equation here is when n is equal to 20. So you guys could see something like this on your test. Obviously, since I'm not going to give you a calculator, the numbers would have to be more manageable because it's not realistic to have you guys make that computation. Okay, so I want you guys to try number 2. It's the same type of idea. Pause the video to do that, and then when you're done, you can turn the video back on, and we'll go over the solution to it. Okay, so number 2, very similar. The way the problem is written is a little bit different, but the approach we're going to use is the same. So again, we're going to start with this formula here, S sub n, which is n over 2 times a plus a sub n. Again, we want to solve this equation here for n. So we're going to plug 2800 in for S sub n. We don't know what n is. Okay, so we have n over 2 times, we know the first term a is 16. The problem is we don't know what the nth term is. So just like in the previous example, we're going to take this formula here, where a sub n is a plus n minus 1 times d. And then we're going to use that to write a formula for a sub n. Okay, so a sub n is a, which is 16, plus n minus 1 times the common difference, which is 8. When I distribute 8 across those two terms, we get 16 plus 8n minus 8, which makes a sub n equal to 8n plus 8. Okay, so we're going to plug that in for a sub n over here. So we're going to plug the expression 8n plus 8n. So that makes 2800 equal n over 2. And then when I simplify what's inside the parentheses, we get 8n plus 24. Now, I know in the last problem I multiplied both sides of the equation by 2, but I don't have to do that here because if I distribute n over 2 across both of these terms, that's going to get rid of the fraction. Okay, so that's going to give me 2800 is equal to, when I distribute, I get 4n squared plus 12n. And then I'm going to move everything to one side, so we get 4n squared plus 12n minus 2800 is equal to 0. And then I can go ahead and factor a 4 out. So when I do so, that gives me n squared plus 3n minus 700 is equal to 0. And this, it's not easy to factor, but it's easier than the previous one. That's actually going to wind up factoring to n plus 28 times n minus 25. So our two solutions for n are negative 28 and 25. So again, just like with the previous problem, it doesn't make sense for the number of terms to be a negative number. So we're going to omit that solution, and the number of terms in that sum is going to be 25. Okay, so that's going to be it for the lesson on arithmetic sequences and series. And then you guys are going to take your quiz on the first two sections of this unit on Monday. Okay, so the first lesson on sequences, and then this lesson, arithmetic sequences and series, quiz is going to be on Monday. Okay, guys, that's it. Hope you all have a great day.